Hello, everyone. Just getting everybody in, so give it a few minutes here. Hi, Lizeth. Hi, Danielle. Hi, Ashley. Hi, 321. Hi, Allison. You got your camera on. I'm saying hi.
Hi.
Danielle, you look like you got a haircut. Did you get a haircut? I'm jealous.
Oh my goodness, my camera doesn't work.
I don't know how to do it. There it is. There it is.
Okay.
I cut my bangs.
Okay.
I'm one of those people. I can't, when they start getting in my eyelashes, I can't. So.
Well, it looks good.
Thank you. And I'd like you to see that my children have colored on my calendar back here. You see it?
Yes, I do.
The outside is still closed.
Ah. All right, we'll give it just another minute here, and then we'll go ahead and get started.
My son shaved his head.
Your son shaved his head?
Yes.
Okay. Well, that's one way to cut your hair.
Hello, Professor.
Hello. How are you?
I'm good. How are you?
Good.
Good, good.
I like your picture there in the background.
This one?
No, well, that's a good one too. I didn't see that one. I'm looking the other way, over your right shoulder.
Oh, yeah, my wife and my son.
Yeah, looks good. Good looking people.
Thank you.
Looks like you had a hand in that. That's for sure.
Yeah.
All right, couple more coming in here. All right, let's get started. I don't think I posted the attendance for this week yet, but I will do that as soon as we're done here on our Zoom. I've had some other stuff going on here today and just didn't quite get a chance to get to it, but I will get to it as soon as our Zoom session's over. So don't forget to post in to the attendance to let me know that you were here in this or just watching videos later on or whatever it may be. I do have to apologize. Seems I've had an issue with my Zoom recordings. So if they haven't showed up, that's why. It's not like I didn't put them up there. Every time I went to go put them up there, something was wrong with it. So I think I've resolved the issue. I'm fingers crossed, hoping that that's the case. So if so, then you will see this video from our Zoom up shortly tonight, hopefully, or tomorrow morning, something like that. But it'll be up there then if I've resolved it correctly. I think I did. I did do some troubleshooting on it, but I think I've got it fixed. All right. All right. Everybody hear that noise in the background? I hear that noise. There it is. All right. Thank you. Whatever that was. I'll mute everybody if I have to, darn it. I won't. I don't want to, but I will. All right. So, excuse me. Everybody hopefully had a chance to watch last week's videos. There was a lot of them, I know. And if you haven't quite gotten to them all, that's fine too. At some point, obviously, you need to get to those. This week's a little bit lighter. I think we only have like 8, maybe 7 or 8. I don't know. It's not that many as compared to last week. And I think they're a little bit shorter. Some of them are a little bit longer, but I think most of them are on the shorter end of things, which I hope. It's all about higher order graphing and rational graphing. So it's about fun in graphing stuff. The only part about that I will warn you in those videos is that in some of them, the book doesn't have a very good example as far as homework to do. So I have made up my own examples and I have assigned those at the end. So be prepared when you're watching that video to hit pause so you can write down what exactly the problem is. Obviously, you're not going to get the answer right away, but I will post those answers as well on our announcements page on D2L. So if you're looking, once you do those problems, do the problem first, try it, and then go look for the answer to see that it matches hopefully your answer or something similar to that. But I wanted to make sure that you're fully prepared for the final exam, and the book does a lousy job of doing that. So I'm taking matters in my own hands, and we're going to do it my way. So if everybody has a problem with that, I guess you can take it up with my department chair or the authors of our book if you can find them. All right. So what questions do you have about what the videos covered last week? We was 4-4 and then 5-1, I think. And then, 5-2. I don't know, 5-2 and then 5. I don't know. It was a bunch of stuff anyway. So I know.
I have a quick.
Yes.
Oh.
Lead us off.
I have a quick general question. What
Okay.
does, and I know you put the definition of it, but what does log mean? I don't understand what that is or what the purpose of it is, or is it just another way to confuse people like me?
No, it's a mathematical term. It's the other side of an exponential coin, right? Because everything has to have an undo in math, right? Every operation that we have has an undo, if you will, right? If you add, the undo is to subtract. If you multiply, the undo is to divide. So the undo, if you will, to exponents is really logarithms. So they're kind of a do and undo kind of thing. It's just a different way of asking a question. Rather than asking a question every time and saying, what power would make 3 into 27, which is 3, by the way, because 3 cubed is 27. Use a log. And you say log base 3 of 27 equals what number, right? And so it's just a long way of saying that, but that's what logs are used for. More importantly, for higher order math, logarithms are there so that we can solve for exponents, really. We use it in calc for that. We use it in statistics for that. We use it in financial mathematics for that. So without having a logarithm, it's kind of impossible to solve for items, unknowns that may be in the exponents of something. So hopefully that works for you, Danielle. Either way, it's next to calculus, you tell somebody you're studying calculus, and that will usually intimidate them if they don't know math very well. The next thing, if you tell them you're studying logarithms, that will also intimidate them. So if you really want to intimidate people around you in your homes, because I'm sure most of you are still stuck in your homes these days, if they say, or if you get on a Zoom with somebody else, they say, what are you studying? You say, I'm studying logarithms. And they'll probably do something like this. Get away. So because they just don't have that good of publicity, I guess, over math. So
I have questions with 5.3 example 9.
okay.
So I'm totally confused there.
All right. Well, let's put up the whiteboard here and see if we can unconfuse you or confuse you more. One of the two. That's my goal. Hopefully to unconfuse you, not confuse you more. All right. So you said 5.3. And then
example 9 and all the, everything that involves it, because I really didn't understand anything.
Well, the key to logs is the 5 or 6 rules I think I gave you in the videos. And that brings up a good point too I wanted to make, which is, those things that I had put into the videos, like logarithms, and I think I've given you 5 or 6 rules for that. And some of the other things that you're going to see here coming up, they're going to look pretty nice because I've typed them up already. And so I plan to share that sheet with you, formulas and steps and everything else, once I have it, finished off here. So expect that hopefully to happen this weekend, to have that. So you'll have that for things going forward. But that's the key, really, Lizette, is those steps. And, one, the definition of log is huge when you go to solve things. And the other properties work too. But, I mean, usually definition is what it comes down to. So if we look at something similar to example 9, let's see if we can pick out something here from our homework that maybe you didn't do or something along those lines here.
I couldn't do anything.
Okay, so I got 2 logs here. All right, I don't know if I asked you to do 34 or not, but let's do that one anyway. That seems like a good problem. Yeah, I think we can do that as a problem. All right, so in 5.3, Let's look at number 34, see if that helps give some clarity here. So this says log base 2 of x equals 3 minus log base 2 of 2x. Now remember, here's the important part here. If it has a base, they're going to tell you the base. If it doesn't have a base, it does have a base. It's just base 10.
Okay.
So if you see log with no number next to it, that means base 10. If you see ln, that's a special kind of base. That's a base e. And e is just a number. It's much like pi. It's a number that we found in nature. It just goes on forevermore. So, but anyway, in this problem, so the first thing you want to do is you want to get both of the logs on the same side of the equal side. Much like if we had x's and you were going to solve for x, you know, one of the first steps is always gather your x's together. So in our case, we're going to gather the logs together. So I'm going to take this negative log 2 of 2x from the right to the left. So I'm going to have log 2 of x, which was there, now plus log 2 of 2x, because I'm bringing that one over, and it still equals now just 3, right? So all I do is move the log to 2x from right to left. All right. Now on the log that we do have, we have 2 logs on the same side. And so now we want to use those rules 4, 5, and or 3, 4, and 5 from the sheet I gave you. Anyway, the product rule, the quotient rule, and the power rule. And we want to use the product rule because we've got an addition. What we want to do is get this down to 1 log. We've got 2 logs. That's fine, but I want 1 log. I can't solve it unless it's 1 log. So I got to consolidate. And the plus says, go ahead and multiply these 2 things together. Right. So we're going to have 1 log base 2, but it's going to be x times 2x, which we call 2x squared. And then it equals 3.
Oh.
All right. You with me so far?
Mm-hmm.
Okay, now we rely on the definition of log. The definition of log says that the base of the log is the base of an exponent. That's one of the things that's great about base and base. The power of this exponent is what's on the other side of the equal sign. That's the 3. So it's going to be 2 to the 3rd power is equal to 2x squared. And the logs are gone. By using definition, the logs disappear. And then we solve it like we would normally solve it. You know, 2 cubed is 8. You still have 2 squared on the right. We would divide 2 on both sides. Looks like 4 is going to be equal to x squared. And then we would take the square root of both items here. And in a technical sense, you get plus or minus 2 to this. Right? The square root of 4 is plus or minus 2. But here's the problem. When you're dealing with logs, the x value of a log, so let's see here, log, let's see, we'll call this b, let's call this m. All right. Yeah, I don't like that M there. Hold on. Let's do that as an X here. There we go. Oops. All right, so let's put it back in the regular definition. Here we go, X. Log base B of X equals Y, right? Here's the thing. X, this value of X, or what we call this value right here, X can never be negative. So even though the answer technically is plus or minus 2, really the answer is only positive 2, because X can never be negative. Y can be negative, B can be negative, but X can never be negative. When it comes to logs, it just doesn't work. You can't have a negative X. But everything else can be negative. So, but when you get something like plus or minus 2, obviously we just throw away the negative because it can't be negative. Just one of those things. Did that help any?
Yes, I guess. So I guess I'm confused when it's the base, because you know the example gave the base and it threw me off.
Okay, yeah. I mean, you know, it doesn't. You know, if you see log and you like writing it with bases, you can always say that means the same as log base 10 and just write that instead.
Okay.
And same with this. If you see ln and you don't like that, you can always write this as log base e.
Okay.
There's nothing wrong with it. If that helps make your rules work better, great. I mean, because it means the same thing. It's just this is shorthand. You know, people wrote log 10 so many times, they just said, let's just call it log. It's just kind of like writing this. We don't put the 2 on the outside of it because it always means square root. Just like log always means base 10. That's why they didn't do it that way.
Got it. Thank you.
You're welcome. And that, let's see, the change of base rule, right, is there because our calculators only have 2 bases of log, right? They've got log base 10, log on your calculator, and ln, log base e on your calculator. They don't have anything else. So if somebody says, what's the log base 2? We don't have that. But that's what the Cobb rule, the change of base, is for. It allows us to use log or ln to find the answer. Other questions?
I do have a question in the same section 5.3,
Okay.
number 27.
Okay.
Can we
All
please
right.
do that?
Yeah, let me clear this off here and we'll go ahead and do that. All right, so 5.3, number 27 says 5 plus the natural log of 8x. They put it in parentheses. You know, as long as we realize the 8x goes with the natural log, we're good. I don't always necessarily use parentheses. If there's something next to it, I might, but I mean, it's not necessary. But feel free to write it in if you like it. Okay, so we got 5 plus natural log of 8x equals 23 minus 2 natural log of x. Sorry, my dogs are going off at something. All right, so much like the last problem, we want to gather our logs. Hey, it's not like I'm on a call or anything. Okay, sorry, class, about that. All right, so we want to gather all of our logs or natural logs on the same side. All right, so since this -2 is natural log over here, I'm going to bring all my logs or natural logs to the right. So we're going to have natural log of 8x. I'm sorry, left. 1 second. All right, so natural log of 8x plus 2 natural log of x is going to be equal to 23 minus 5. Okay, hopefully they'll calm down here. Sorry about that. Goodness gracious. Okay, I'll admit that. Okay, so 23 minus 5 obviously is 18. Hopefully we can all do that math together. And then you've got the 2 natural logs here. All right, so for us to proceed here, first we want to reverse the power rule. So anything that's in front of a natural log, in this case, we want to put back to being here, right? So this 2 needs to go back to being a power of the x in this particular case. So we're going to have natural log of 8x plus natural log of x squared, still equal to 18. All right, we want to do that because we want to definitely combine these at some point here. Now, another way we could have done it was to divide by 2, but since we can't divide everything by 2, that'd have been a little bit weird in our 2 logs, right? Had this been a 2 in front of this log 2 or a 4 or something, yeah, we could have divided everything by 2, but since it wasn't, we want to put it back. All right, then our rule says with the plus, you combine them as a multiplication, right? And that multiplication is going to be 8x times x squared, which we're going to call as the natural log of 8x3, so equal to 18. All right, so natural log of 8x3 equals 18. Again, that's 8x times x squared. That's how we get 8x3, as we multiply them together because of the plus. If you look over on page, just make sure we're on the same page here. Let's see, where is that rule at? I think it's in 5.2 actually, is where that's located. But in 5.2, this would be rule number 6 there that they have on their page, 336. So we call it the product rule. So, all right. Then we take the rule or the definition of log, right? So natural log is a base of e. So it says e to the power of, what's on the other side of the equal sign, 18. So this is going to be a very large value, equals 8x cubed. All right, so for us to find the answer, first we got to divide both sides by 8. So we're going to have to take e to the 18th divided by 8. So we'll have e to the 18th divided by 8 equal to x cubed. And then we're going to have to take the cubic root of both sides in order for us to get the answer there, or otherwise known as the 1/3 power, right? So essentially what you're doing is this. You're going to do E18 divided by 8, and then once you have that, you're going to ask the calculator here for the 1/3 power, and that's going to give us our x value to solve. All right, so we'll bring our calculator out here and see if I can do it step by step. So the first thing I'm going to do is e to the 18th. So in my TI-84 plus, I'm going to hit the second button, and then I'm going to hit the LN button, which tells me E. It says E to what power, and I say 18. I close parenthesis on that, hit enter, and it's a very large number. I think it's, let's see, 1, 2, 3, it's 65 million. So it's pretty large. Divided by 8. And then I take the cubic root of that. So I'm going to take this to the 1/3 power. And it's still an exceedingly large number, according to what I got. I don't know. That doesn't make sense. All right, hold on here. Must have done something wrong. Girls, come on. Sorry, my dogs are killing me right now. Okay. Oh, funness. Okay. Let me try that again. I think I screwed something up here. All right, e to the 18. Let's get that large number divided by 8. Get that. Take it to the power of 1 divided by 3. All right, still slightly a smaller number. No, what happened there? Oh, goodness gracious. Anyway, that's how you would get to the answer anyway, so we'll just leave it at that. So that's the steps, though. How did that work for you, Sarah? That was your question, right?
Yes, that worked very good. I did not know that we can, like, I think in step 1, 2, 3, 4, I think I didn't do the step 4. Whenever, no, I mean 1, 2, 3, and 3, like the step 3, whenever it was ax plus x, like square, and then you combine it.
Okay.
That's work. Thank you. Thank you so
Okay.
much.
You're welcome.
Oh,
All right, what else do we got? Let's clear that off so we have some space.
I had 4.4 problem 19.
Okay, let's take a look at that as soon as I can find it. 4.4, there we go. 19. Okay. So this is 2x to the 2/3 plus 5x to the 1/3 minus 12 equals 0. All right. So we want to do a u substitution here, and we would do this because I see the first power, 2/3, is twice the power of the middle one, 1/3. So it's perfect time to do a substitution here and say that this is equal to, u is equal to x to the 1/3 power. Because what that does is it gives us 2u squared plus 5u minus 12 equals 0. All right, so now we see we can factor this. I think we can, because 2 times 4 is 8, and 3 times 1 is 3, and 8 minus 3 should be 5. So I think I factored this correctly. And if not, I could always do an OI check, but I'm pretty confident that it's factored correctly.
Jeff,
Yes.
I have a question.
Uh-huh.
Oh, there go my dogs.
Yes, what is your question?
My question is, where did the U come from in step number 2?
Well,
Right there.
we put it in there arbitrarily to help us solve this.
Okay, if you say so.
Yes, I say so. You don't have
I
to
know-
use U, but it's the best letter to use.
I know what I did wrong in that one.
Okay.
All right,
I
well, let's-
forgot the 2.
Oh, darn it.
I was just counting for U's and I couldn't factor. I was like, what the heck?
Well, that would do it, I guess. All right, so then you'd solve for U, but then obviously you need to say that U is equal to 1/3 x right here, or x to the 1/3, sorry, and then which really means the cubic root of x. And so you'd have to cube both sides in order to find x in this case here. So looks like there would be few x answers, 2x answers anyway. So what else do we have?
Can we do 4.421, please?
No.
No?
All right, just kidding. We can do 4.421. All right, let's clear this off. Let this go. All right, clear that, clear all drawings. Okay, so 4.4 number 21. So we have x squared plus 4x is less than 0. All right, so remember our trick here. Our first trick is we pretend it equals 0 for a second. But before I even do that, this function is less than 0. So we're going to be looking for negatives here in just a minute. So I want to put a negative there because it's less than 0. If it was greater than 0, we're looking for pluses, but we're less than 0, so we're looking for negatives. All right, so if I pretend it equals 0 for just a second, and I say that x squared plus 4x equals 0, and try to solve it. Well, what I would do is I would factor an x from both of the items that I have. So I would say x times x plus 4 equals 0, which means that x is 0, or x plus 4 equals 0,
Minus.
and x is negative 4. So those are what we call our critical points. Now we could go back to the original. We could rewrite this also as x times x plus 4. It's easier to rewrite it as a multiplication if you can, because doing the test points next is easier with a multiplication. Okay, so now we draw a number line, and we stick on our two critical points. We got 0, and we have negative 4. All right, and then we draw some regions down to it, some dashed or dotted lines to it. And so we have three regions, right? We have the region that is negative infinity to negative 4, the region that is negative 4 to 0, and the region that is 0 to positive infinity. The answer is on one or more of these regions.
Negative.
Okay. All right, so now we need a test point. And what we test is we pick a point that's in the region and we stick it in for x right here into this equation. And we ask ourselves, are we going to get a positive or a negative? We don't care about the number itself. We just care if it's positive or negative. All right, so let's do the positive side. So 0 to positive infinity. I'm going to pick 10,000 as my number. All right, I don't have to put it on the number line, but just for purposes, I will put it here so you can see it, 10,000. So I put 10,000 in for this x. Is that positive or negative? That's positive. And 10,000 plus 4, is that positive or negative?
Positive.
Positive. And a positive times a positive is
Positive.
a positive. All right, so that means this isn't a region for us because we're looking for negatives. So this is a region that we don't have an answer on. All right, let's do the other side. Negative infinity to negative 4. All right, I'm going to choose negative 100. A little bit smaller, but still kind of a big number. Negative 100 goes to this x, which makes a minus. Negative 100 plus 4, that's also a minus. And a minus times a minus
Positive.
is a plus. That's also not a region of answer. All right, last but not least, we have the region between negative 4 and 0. All right, and so in here, we need to pick a point. Now, we have to be careful which point you pick because there's only so many points between negative 4 and 0. So let's go negative 2 right in the middle. All right, so if I put negative 2 in for this x, I get a negative. If I put negative 2 in for this x, I get negative 2 plus 4. Well, that's still a positive. And again, these are being multiplied, which is why I'm multiplying these two things here. Negative times a positive is a negative. And there you go. That's our answer. Our answer is between negative 4 and 0. Because I'm looking for negatives. At the beginning, I said, what are we looking for? We said negatives. There's our negative right there. So now we get to say our answer is negative 4, comma 0. It is less than 0, nothing equal to. So both of these get to be rounded. If it was equal to 0, then we'd square them. But it isn't, so we'll round them. And there we go. That's how you do these problems. You want to create what's called a sign chart. It's called a sign chart because you're putting in signs, as in plus, minus, plus, whatever it may be. And then that's where your answer is going to occur. You say, yeah, if I, because what's the difference between this problem and this problem? X squared plus 4x is greater than 0. Well, the difference is none of the steps change. The only difference is the end answer, because this is greater than 0, the answer would have been negative infinity to negative 4 and 0 to positive infinity, of course, with our brackets around these and the u in between there. So that's the only difference, whether it was whether it was greater or less than 0 is the end result. The steps don't change.
So that applies to everything, all the inequalities that are like that, right? That where the function is less than
Yes.
a number.
Well, I mean,
0.
Well, we can't always say that it is in the middle here, if that's what you're meaning. I mean, we have to do the sign chart to figure out where it's going to be.
Okay.
But the steps are the steps are the same. So, I mean, you're going to get one of two answers. It's either going to be the two outsides or the one inside. Those are the only two kinds of answers you can have, unless there's somehow more critical points. You know, I think generally deal with only 2 critical points. But if there was like 3 critical points and the regions got bigger or more regions of them, yeah, then you could have slightly different answers of things. But generally, we don't go more than 3 or 4 regions tops. But I think 3 regions is kind of where it's at for us. But whether it's negative or positive, whether it's less than 0, greater than 0, again, the steps don't change, just the end result does. That's the only difference in your answer is what are you looking for? Well, I was looking for negatives. Ooh, there it is. Oh, wait, I was this one here. I was looking for positives. There it is. So if it's 2 regions, don't forget the U in between them. Because that's how you're joining them and saying it's this one or that one. Really both, but it's an or. Math likes to practice what they call an inclusive or. Anybody ever heard that term before, an inclusive or? So most of us are used to the English form. It's called the exclusive or. So it'd be like, let's say I'm going to give you a piece of candy on Monday or Wednesday. And on Monday you come in and I give you a piece of candy and you're like, great. And then Wednesday you come in and I give you a piece of candy. And you go, wait a minute, you said Monday or Wednesday. And I say, well, I was talking about the math or, because the math or actually means both, which is the stupidest or in the world. In our law, we call that and, not or. So, but yeah, that's what math practice is called exclusive or. So even though this technically this U is or, it's really an inclusive or, which really means it includes both of these regions or one of these regions. So it kind of goes both ways. But what other questions do we have? We're getting low on time here. We have roughly about 9-ish minutes left. Actually 8 minutes and 28 seconds according to my timer at here. So I definitely have time to get 1, maybe even 2 more questions in here.
Thank you so much, Jeff.
You're welcome. And, you know, if you're, you know, again, I will also say, you know, if you're having any issues with this, you know, there's 2 avenues for you to get help. You know, the tutoring is online with our tutoring center, and again, still free. I think they do it via Zoom or WebEx or something like that. And again, if you can find time in my schedule, which I'm sure we can figure out, hopefully, email me and we'll figure out something. We could do our own Zoom together. And we can go through a few more problems that way too. But yeah, if you're having trouble, just let me know. I mean, that's what my email's there for you guys to communicate with me and let me know what's going on. So other than that, how's everybody else feeling? Feeling good?
Good.
Good. Anybody enjoy the video for the 5.5? Jared, I was thinking of you. Did you enjoy that one?
I haven't seen that one yet.
Oh, Jared, you rat.
Anybody else? One with the video clip?
Yes, the one that the lone video. There's a video clip in it, embedded video clip. So
yeah, and I remember now the shampoo as well. That makes it really helpful.
The shampoo equation. Yeah, I try to bring in pictures when I can. I think that, you know, that's one thing, at least in a video form, I can do versus doing it in class and saying, imagine what a shampoo bottle looks like. So, or imagine what PERT looks like. Or whatever it is. That's right. You see, I muted you myself. That's okay. I have the power to mute anybody I want to, including myself. Except if I mute myself, then my mouth's talking and you're all wondering about your own sound. So that I try not to do that too much.
So next weekend, next Friday, we're gonna review for the test. What we're gonna see on the test. I'm sorry.
Sort of. I mean, that's a good point to bring up. So this week you're going to focus in on videos for 6.4 and 6.5. And like I said, there's a handful of those. And since Liza, you were the one talking, did you get my email about being able to filter down the results so you can find the videos more easily?
Yes, okay, I did. Because I was a mess. I was jumping from one video to the other.
If anybody else
I figure it out.
No, if anybody else is struggling on YouTube to find the right videos, once you get to my page, there's a little magnifying glass on it, I think, toward the top of it. If you click that magnifying glass and type in like 120 or type in, 5.4, whatever section we're supposed to be doing, it'll filter everything down to just those videos. Anyway, but yeah, it's a good point. Let's talk about the schedule. So this week here, so after tonight, again, videos should post at 8 o'clock here tonight. So sometime between now and next Friday, watch the videos for 6.4 and 6.5 sections. And then next Friday, we'll talk about questions on those. That's graphing stuff. And then I will also give you the review sheet. So I don't know if I have it ready before then or not, but much like the videos, there's a review package that the department has put together that'll prepare you for the final test. And so I'm going to do videos this weekend on the examples or on the questions on that review package. So that way you have sort of you can try it yourself, and then if you don't get it, you can go look at the video, or you can watch the video, then try it yourself, or whatever you want to do. I would suggest you do it the other way, I guess, but I'll talk about more of that next week. And then when we come back the week after that, we'll be talking about the review package and questions you have, because that's really our final night. That's when you'll take the test. So, but we'll meet a little bit earlier than usual so we can go over questions about the review package or anything else that you're concerned about. And then once we're done with that, then I'll release the test right after that so everybody can go ahead and do it. So be a little bit different than normal. But again, so there's going to be a review package. And again, the great thing about the review package is the test, the final test is a subset of that package. So if you can do everything in the review package, you are prepared. I mean, the test is way less questions, but all of the questions from the test come from some of those review questions. I mean, they're not the exact same numbers, but the exact same process. And not everyone makes it, but enough of them do. There's nothing outside the review package that's in that final. Let's put it that way. So again, the review package is your big guide. If you can do the review package, you're ready to rock and roll. There's nothing on the final that's not in that review package. There's things in the final that aren't on the review package. Oh, sorry. There's things in the review package that aren't on the final. There we go. Not the other way around.
How long are we gonna have to finish the test?
So I'm still working on that, but it should be, at least 4 to 5 hours. So, and what I'll do is I'll post it, we'll post it at like 8 o'clock or something like that. And then, or I think 8 o'clock, whatever. I got a time for it, but I'll let you know that. So anyway, you post it like as soon as we're done with our Zoom session, basically, and then it's supposed to be back in my inbox by whatever time we set. So in preparation for that, it's a good point to bring up. What you will do is, if you can, print the test out of yourself and do it that way. And if you can't, that's fine too. Use the electronic form. You have your own piece of paper, and you can write down each number that you're doing. Whether that means one per piece of paper or many per piece of paper, I don't care. Whatever makes it clear to do. And then you're gonna send those results back to me. So there's an app I found that's really good for that. It's called Genius Scan. If you have a scanner in your house, you can just scan them in as one file and send it to me that way. But if you don't have a scanner and you're using your phone, that's fine too. Genius Scan is an app. It's free for iPhone. It's free for Android. It allows you to take a picture of each page that you want to take a picture of. You can crop out anything else that you want. Let's say you take too wide a picture and you got like table or something in your shot versus your actual paper. You can crop it down to just your paper. You can build a file which has multiple pages in it, and then you could send me one PDF file which has all of your tests in it, as opposed to sending me like 15 scans, because it took me 15 pages to do, Jeff, and I send you 15 different. I don't want 15 things. Okay, I want one file if you can. And Genius Scan I found it's a free app. It works really good for that. There are other apps that do similar things, but Genius is the one I tried out, and it worked really well, and it was fairly intuitive in how to use it. So you took a picture, it said, all right, are you done? You're like, no, I got other pictures. And you just kept taking until you said done. Then it was like, okay, well, how do you want to save this? And you could save it as a PDF or as a PNG file. I would prefer PDF, and then send it to me that way. You can send it to yourself and then forward it from there to me, and that way, it went somewhere. There's never a lost in translation. Especially if later I'm like, hey, I didn't make my inbox. What happened? And you're like, I sent it. And it's like, well, I don't have it. And you're like, well, let me check my own inbox. So there's ways to do that, right? So it gives us both some accountability. So if you get a chance, download that. At some point, I will bring it up again next week, though. But Genius Scan, again, is the one I found, and my son has used it, and I've used it. And it works pretty good. But if you have a computer and you've got a scanner at home too, you can feel free to scan it and do it that way. That's fine too. But I know a lot of us don't have that equipment.
Thank you, Jeff.
You're welcome. All right, we're in our last minute. Any final thoughts, questions, concerns? All right, stay healthy. I care about every one of you. We're gonna make it. This thing's gonna turn at some point, and we'll all be back to normalcy whenever that is. Whenever. So, stay healthy. Wash your hands. I'll see you next week.
You too. Bye-bye.
Bye.
Bye. Bye.